In this video, I want to go over some details on working with mutable objects. In Python, variables are references to objects in memory, and when you assign an object to a variable or pass it in as an argument to a function, the variable or function parameter becomes a reference to that object. If you assign a new value to that variable or modify the object through that reference, the changes are reflected everywhere that reference is used. This behavior applies to mutable objects such as lists, dictionaries, and sets. Understanding the concept of reference and copy is crucial when working with mutable objects in Python to avoid unexpected modifications and maintain data integrity. In my development environment here, I have a function that is set up and ready to go that is going to demonstrate that when you change a reference, it is reflected everywhere that that reference is used. As you can see, I have a function here called reverse list that takes a single parameter. In this case, I am going to pass a list into it. And this function is going to output my list before reversing, then it's going to reverse the list, and it's going to output my list after reversing. And then after we make a call to this function, we're going to print the cars list. And what we're going to see is that although we're calling reverse on this function argument here, it actually affects the list that is outside of the function. And when I run this, we'll get three outputs. We'll get my list before reversing, and I have Ford, Chevy, Dodge. And then I have my list after reversing, so it's Dodge, Chevy, Ford. But then when I print my cars after calling the reverse list function, it's also Dodge, Chevy, Ford. And what we can see here is that my cars list was reversed even though I called the reverse on my list up here in the function. And that's because when I pass cars in as an argument for this, I passed a reference to that object. And since the object is mutable, the changes are on the object itself. Sometimes this may be perfectly fine. This may be something that we want to actually change the referenced object. Other times we may want to work with the elements that are in the reference object, but not actually change the object. And the way that we can do that is by passing a copy of the mutable object in instead of the mutable object itself. So I'm going to spend some time in this video showing you how to make copies of mutable objects to work with. So I'm going to remove this code and add some new code. And if we look over this code, we'll see I have an import statement where I am importing the copy module, which allows us to make shallow and deep copies. I have a list of numbers that I am going to be working on. And in my list, I have three values, 1, 2, and 3. And then the third index is a list containing the numbers 4, 5, and 6. I have an exact copy variable that is just going to equal numbers. So when I do this right here, exact copy and numbers are both going to reference the exact same object. Then I have shallow copy 1, which I am creating a copy of numbers by using the built-in list method copy. Then I have shallow copy 2, where I am creating a copy by using slicing notation with a pair of square brackets and a colon, and I'm leaving it blank on the left and right side of the colon to copy the entire list. Then I have shallow copy 3, where I am using the class method copy from the copy module. And then I have deep copy, which uses the class method deep copy from the copy module. And down here, I have an if conditional statement to check if numbers is exact copy. And if we'll recall, when you use is, it is checking to see if it is the same object. So when I run this, we'll get the output, yes, numbers and exact copy are the same object. So this variable here and this variable here are the exact same object in memory. Now, if I remove this, I have some more code here. And if I uncomment this out, we can look at this. And now I'm checking to see if numbers, exact copy, shallow copy 1, shallow copy 3, and deep copy are not the same object, but all contain the same values. And if they do, this will output that all 5 lists have the same values. And when I run that, we'll see that it does, in fact, output all 5 lists have the same values. And if I included copy 2 in here, it would also have the same values, but it was getting a little long on the text and it was going off the screen, so I left it out. But it basically shows that all 6 of these lists here, even though they were all created in different ways, have the same values. But they're not necessarily the same object. And if I remove this, I can bring up some more code. This time I have an if-else conditional. And we're going to check if numbers is shallow copy 1. So are numbers and shallow copy 1 the same object? And if it is, it's going to print numbers and shallow copy 1 are the same object. Else, it's going to print numbers and shallow copy 1 are not the same object. And when I run this, we'll see that I get the output numbers and shallow copy 1 are not the same object. This is because we used the built-in copy method to return a copy of the list to put into shallow copy 1. And if I remove this, we have another if conditional here where it says if numbers 3, so the element that's at index 3 is the same as shallow copy 1's element at index 3. So this is again checking to see if the element that's in index 3, which is this list right here, is the same object as the element at index 3 in shallow copy 1. And when I run this, we'll see that we get the output. The list in numbers and shallow copy 1 are the same object. And this is why it's called a shallow copy, because it only copies the outer structure of the list, not the elements inside. The copied list contains references to the same elements as the original list, but if the elements are immutable, such as numbers or strings, modifying them in the copied list won't affect the original list. However, if the elements are mutable, such as lists or dictionaries, changes made to those elements in the copied list will also be reflected in the original list. And to demonstrate that, I will go ahead and remove this code. And what I'm going to do is change the shallow copy 1's first index, the 0 index, to be a 7. And then I am going to change the shallow copy 1's third index's first index to be 8. So where this 5 is here will be 8 in shallow copy 1. And now I'll print out shallow copy 1 in numbers, and we can see how those changes have affected these lists. So I'll do numbers first and then shallow copy 1. And when I run this, we'll get these lists where we have 1, 2, 3, and now I have 4, 8, 6 inside the inner list. And then for shallow copy 1, I have 7, 2, 3, and also 4, 8, 6. And this shows that this 7 was changed in the shallow copy 1, but it did not change in the numbers list. However, the inner list changed to 4, 8, 6 in the numbers list when I changed it to 4, 8, 6 in the shallow copy. So I'm going to go ahead and remove that, and we'll look at how a deep copy works. So I have this code here that I will uncomment. And it says if numbers 3, so this inner list, is deep copy 3. So it's looking at the inner list inside our deep copy here, and it is checking to see if it's the same object. And when I run this, we get the output. The list in numbers and deep copy are not the same object. And I will do something similar with the outputs here. I will change deep copy's 0 index to 7, and I will change deep copy's third index, first index to 8. And then I will print out the numbers and deep copy list. And when I run this, we'll see that numbers has not changed at all, including the inner list. It is still 4, 5, 6. But for my deep copy, I have changed the 1 to a 7, and the inner list is now 4, 8, 6 instead of 4, 5, 6. I just wanted to make this video to demonstrate how to work with references and copies, because this is something that gets new developers hung up quite often. So I just wanted you to see the different ways to create copies and how working with shallow copies when they have mutable objects inside can be affected.